So now let's prove the following inequality so that n is smaller than 2 to the power of n for all positive integers n using induction. So as usual, we start with the base step. So the base step, in this case it's n equal to 1. We're going to check well, it's actually not a left-hand side. We're just going to check if the formula is true for n equal to 1. So for n equal to 1, so this is the left-hand side, smaller than 2 to the 1, which would be equal to 2, is true. So indeed, 1 is strictly smaller than 2, and so this means that this is correct for n equal to 1. And now we're going to do the inductive step. So now we need to show that if it's correct for a number, it's correct for the next number. So let's do the inductive step. So let's assume the inequality for, let's assume the inequality for n equal to k. And so what this means is that we're going to assume that it's true that k is strictly less than 2 to the k. And we need to show for n equal to k plus 1, we need to show that this is true. We need to show that k plus 1 is strictly smaller than 2 to the power of k plus 1. Okay, so k plus 1 is going to be less or equal, so we can start with that, right? So k plus 1 is going to be less or equal. So here we already see that we can use the inductive hypothesis. So from the inductive hypothesis, we know that k is less than 2 to the k. So then this is going to be less than 2 to the k plus 1. And now we would like to continue doing stuff and eventually get, so let me write it up here. We would like to be able to show that 2 to the k plus 1 is smaller than 2 to the k plus 1. So how could we do that? So one way is to sort of look at what we want to show. And so this is, so 2 to the k plus 1 is equal to 2 to the k times 2. And this is equal to 2 to the k plus 2 to the k. So if we're able to show that 2 to the k plus 1 is smaller than this, we're good, but that should be okay because 2 to the k is equal to this part, and 1 is always smaller than 2 to the k, right, for positive k. So what this means, and again, this is just some scratch work that we are using to try to come up with our ideas, and don't mix the scratch work with the proof because then it will be hard to read, but do the scratch work on the side and leave it there. So, or in some place where it's organized, you can write scratch work and leave it in some organized place. But the idea here is that in the proof, we have k plus 1 is smaller than 2 to the k plus 1. And now this is smaller than 2 to the k, and 1 is always smaller than 2 to the k. But this is just equal to 2 times 2 to the k, which is equal to 2 to the k plus 1. So indeed, k plus 1 is going to be strictly smaller than 2 to the k plus 1, which is exactly what we wanted to show. So in other words, thus the inequality, so the inequality holds for k plus 1. And then we conclude, thus by induction, let's write this correctly, by induction, n will be smaller than 2 to the n for all positive integers n.